Uh, Good morning. Today we'll start with isometric projection. Isometric projection is nothing but the representation of objects in three dimension. Okay. So in orthographic projection, the three-dimensional objects were represented in two dimension. Okay. But in isometric, the objects are represented in three dimensions. Okay, but the important points which you have to note here is the objects in isometric will be reduced in length. Okay, you can see this isometric scale. Okay, so this is called as the isometric scale. So if it is visible, you can see here. Yeah, so at 45 degrees you draw a line 45 degrees to the horizontal. On that you mark 10 mm with your scale, usual scale, 10, 20 and 30 mm. Okay, then draw one more line at 30 degrees to the horizontal. Okay, and from the points which you have taken 10 mm, 20 and 30 mm, draw vertical lines to the 30-degree line. Okay, the point at which they cut, that is the isometric 10 mm. Okay, and this is isometric 20 mm and this is isometric 30 mm. So you can see that the size, okay, you can see from here to here it is actual 10 mm, and if you come to the 30-degree line, so the size is reduced. Okay, by how much it is reduced? So the actual size is reduced by 0.816. Okay, so for example, if the actual scale is 10 mm, isometric scale will be 10 into 0.816, that is equal to 8.16 mm. Okay, so this is an important concept which you have to remember. So in isometric projection, the size of the object will not be equal to the actual size. Okay, the next point which you have to remember is in isometric projection, okay, all horizontal lines will be inclined at 30 degrees to the horizontal, okay, as shown here, and that is OX and OY, and all vertical lines will be vertical. Okay, so and this is the concept of isometric projection. For example, you have a square prism. Okay, so here all vertical lines will be vertical. Okay, so these are the vertical lines, vertical edges. All vertical edges will be vertical. Okay, and all horizontal edges, okay, whether it is top base or the base, they will be inclined at 30 degrees to the horizontal. Okay, so you can see this in your sketchbook. You have at the end, this is the isometric lines. Okay, uh, this is the isometric graph sheet, and these are the isometric lines. You can see they are inclined at 30 degrees to the horizontal. Okay, so now coming back to isometric projection, there are two types of lines. You can see there are two types of lines in isometric. One type of lines, they are called as isometric lines. Okay, what are isometric lines? Okay, the lines which are horizontal and vertical. Okay, they are called as isometric lines. Which are non-isometric lines? Non-isometric lines are lines which are neither horizontal nor vertical. That is, they are not parallel to OX or OY or OZ. For example, you can see here, this is a square. So here all lines, all the edges are isometric. Okay, so all lines which you draw will be isometric lines. Okay, then if you consider a rectangle, this also rectangle also, all lines are isometric lines. Okay, but if you consider a triangle, so here you can see the lines are not horizontal or not vertical. Okay, so they are inclined lines. A triangle has inclined lines. Okay, similarly a pentagon. Okay, these are all called as non-isometric lines. Okay, or a hexagon. Okay, so all these are called as non-isometric lines. And a circle, so it is a curved line. So circle also is a non-isometric line. Okay, so isometric line, a prism, all lines or edges of the prism are isometric. They are vertical or horizontal. Okay, so there are no inclined lines in a prism. So all the prism has all isometric lines which will be parallel to either OX, OY or OZ. Okay, but if you consider a pyramid, okay, you can see here, now these are inclined lines, inclined edges are inclined lines, so they are not parallel to either OX, OY or OZ. Okay, so this type of lines are called as non-isometric lines. So you will be learning how to draw the projection of an object having isometric lines, okay, and non-isometric lines. Okay, so first we will take up a square. So this square has all isometric lines. Suppose this is a square of say 30 mm. Okay, so this can be drawn in isometric. We'll take this. You can see the square, this is 30 mm. So take any point on the graph sheet. From any point you start, take 30 mm on one side. So from here to here it is 30 mm isometric, 10 mm isometric, 10, 20 and 30. Okay, suppose this is A, B, C and D. So it is in the horizontal position. Okay, the square you are drawing in isometric in horizontal position. So again from here, this is A, this is B. Again from B you count 30 mm, 10, 20, 30. Okay, so this will be the end point C. Then from again here you count 30, 10, 20, 30. This will be D, and then again join D to A. So you can see this is how you draw a square in isometric in horizontal position. Okay, So if you want to draw it like this in vertical position, okay, in vertical position, you can see two edges are parallel or horizontal and two edges are vertical. Okay, so how to draw that in isometric? I told you all horizontal lines or edges are inclined at 30 degrees to the horizontal. So select any point on the graph sheet. Okay, take horizontally, suppose this is A, 30 mm, so this is B. Okay, now vertical side, vertical also it is 30 mm. So from here to here it is 10 mm. So 10, 20 and this is 30. Similarly from B you take 10, 20 and 30, somewhere here it will come, and join this. So this will be a square in isometric, in vertical position. So you can draw the square in the opposite direction also. Okay, like this. Suppose you take this, start from here, this is 30, okay, and this is 30, this is 30 and this is 30. So you can draw the square like this also, in this direction also. So this is how you draw a square which has all isometric lines. Okay, horizontal, if it is in horizontal position, this is how you draw. If it is in vertical position, this is how you draw. Okay, either this or this. Okay, now similarly you can follow the same procedure for a rectangle. Okay, you can draw the rectangle either in vertical position or horizontal position. Now if you want to draw a triangle in isometric, suppose you have a equilateral triangle like this in isometric, you have to draw this in isometric. You have a equilateral triangle. So to draw this in isometric, what you need to do is you need to find the end points of the non-isometric line. All these lines are non-isometric lines. So you need to find the end points of the non-isometric lines and then join them. You will draw the isometric projection of non-isometric lines in isometric projection. So how can we do that is, you have to enclose this triangle. First you have to draw that equilateral triangle in orthographic projection in the plain paper. Then you have to enclose the triangle in a box. Enclose the triangle in a box. Suppose the corners of the triangle are A, B and C. Then when you enclose it in a box, the corners of the box, let it be 1, 2, 3 and 4. Okay, so now this box has all isometric lines which can be easily drawn in isometric projection. So first draw the box in isometric projection. Okay, so measure from 1 to 2, okay, and 2 to 3, and Okay, 3 to 4 will be equal to 1 to 2, and then again 1 to 4. 1 to 4 and 2 and 3 will be same. Suppose this is, say, 30 mm, and suppose this is 25 mm. Okay, so whatever dimensions you get when you enclose the equilateral triangle in a box, take those dimensions. Okay, then the equilateral triangle is 30 mm in length. Now transfer this box in isometric. So to that, in horizontal position, you can draw this triangle both in vertical position and horizontal position, as in case of square. So now transfer the triangle in isometric. First transfer the box. Okay, so 1 to 2 is 30 mm, that is a horizontal line again. So here we will consider any point here, then take 1 to 2, this is 1, 30 mm you take. Okay, then this is 2 to 3 is 25 mm. So you can see here 2 to 3 is 25 mm. So take 25 mm here, 10, 20, 25. So this is the end 3 of the box. Okay, so draw a thin line. Next, from 3 to 4, again it is 30. So measure 30 mm, draw a thin line. So this is 4, and close the box. So it is very easy. Okay, all isometric lines will be parallel to this 30-degree lines. Now to draw the triangle in isometric, you have to, as I said, you have to find the end points. A is at 1, B is at 2. So we'll take A here and B here and join them. So one side of the triangle we have got. Now to get the lines BC and AC, you have to locate the point C. You can see from this figure, the point C is at the center of 3 and 4. Okay, so take the center of 3 and 4, center point of 3 and 4. So this will be C. Now to complete the triangle, join AC with a straight line and join BC also with a straight line. So you can see now that this is the triangle in isometric. The shape of the triangle is not equilateral. Okay, it is different. Okay, so this is the triangle. This is how you have to draw triangle in isometric, that is non-isometric lines in isometric projection. The same can be done in the vertical position. So take the distance box first. 1 to 2 is 30 mm. Okay, then vertical 25 mm. So from here to here it is 10, 20, and this is 25. Okay, then again from here to here it is 30 mm. Then again from 2 go vertically up 25 mm. So you will get the corners of the box 3 and 4 and 1. So to draw the triangle, A is at 1, B is at 2. Okay, so join AB with a straight line. Then C is the midpoint of 3 and 4. take the midpoint of 3 and 4 and join, this is C, join AC and BC. So this is how you draw a triangle in isometric. Okay, similarly I'll tell you how to draw the pentagon in isometric. You know, a pentagon has all non-isometric lines. So how to draw the pentagon in isometric? These are the basics or fundamentals which you have to know. Okay, so if you are thorough with this, you can easily draw the three-dimensional objects. Okay, so coming to pentagon, as I said, to draw non-isometric lines in isometric projection, you have to first draw the orthographic projection of the pentagon, then enclose that pentagon in a box. Okay, so we'll draw the orthographic projection of a pentagon. Suppose the sides are 30 mm, say, a regular pentagon. Okay, then this is 108 degrees, you know. Again measure 108 degrees here and draw the 30 mm line. Okay, then from again here on measure 108 degrees, then draw a line equal to 30 mm, and from here again measure 108 degrees, draw a line to touch here. So this is I'm drawing it with freehand. You draw using the scale. Draw it according to scale. Now you have to enclose this in a box. Okay, so I'll draw the box here. So now I have enclosed the pentagon in a box. I'll name the corners of the box as 1, 2, 3 and 4. Okay, then the corners of the pentagon, we'll name it as A, B, C, D and E. Okay, now to draw the pentagon in isometric, you have to measure this distance 1 to 2. 1 to 2 and 3 to 4 will be same. So measure this distance. Suppose it is 30. Okay, or let it be 35 mm. Suppose this is 35. You draw and measure it, whatever comes there you can take that. Then suppose this is 40 mm. This is just for showing you how to draw the pentagon in isometric. Okay, now reproduce the box first in isometric. 1 to 2 in horizontal position will draw it. First take any point, okay, in the sheet. 1 to 2 is 35 mm, so go 35 mm horizontally. 10, 20, 30, 35. So this is 2. Okay, join this. Next 2 to 3, okay, is 40. So go parallel to the 30-degree line here, from 2, 10, 20, 30, 40. Okay, next, this is the corner 3 of the box. This is the corner 3 of the box. Okay, next, from 3 again 35, come here. So this will be the corner 4, and from here 1. So you have drawn the box in isometric. Now to draw the pentagon in isometric, I told you have to locate the end points of the lines. Okay, how to locate the end points of the lines? If you want to find out A in isometric, okay, measure the distance from 1 to A. Okay, measure this distance and 4 to E, and this distance will be same because it is a regular pentagon. Okay, so on which line it is? On the line 1, 4. Suppose this is say 8 mm. This is also 8 mm. Okay, whatever you get. Now come to the isometric drawing. Here 1 to A is 8. So from here to here it is 5. Approximately 8 will be somewhere here, just before 10. So this will be your corner A of the pentagon. Next, from 4 you have to measure 8 mm. 5 and somewhere here it will be 8. So this will be your corner E. Okay, similarly, to find out the end B, okay, so measure the distance from 1 to B. Okay, this will be same as 4 to D. So this distance and this distance will be same. Okay, suppose this is say 20 mm. Okay, so this distance is suppose 20 mm. Whatever you measurement you get, you take that 20 mm. Now I have to transfer this in the isometric. Where 20 mm to get B, I have to transfer 20 mm on the line 1 to 2. Okay, so come to the isometric projection 1 to 2, 20 mm. So from here 1, 10, 20. So this is your corner B. Similarly, here from 4, this is 10 and this is 20. This will be your corner D. Okay, so you have got 4 points of the pentagon. What is left is the 5th point, which is C. You can see from the figure, C is the midpoint of 2 and 3 of the line 2 and 3 of the box. Okay, so come to the isometric projection. So this is 2 and 3, midpoint of 2 and 3 will be here. So this will be the corner C. Now join all the points A, B, C, D. You will get the pentagon in isometric, which has all non-isometric lines. Okay, so A to B join with a straight line, B to C, C to D, and D to E, and A to E. So this will be the pentagon in isometric. So you can draw it in vertical position also. The procedure is same. Instead of horizontal, the box will be in vertical position. Okay, so this is the introduction about isometric projection. So here one more figure I want to show here is how to draw a circle in isometric. Okay, so how to draw a circle in isometric? You know, this circle has all non-isometric lines. It is a curve. Okay, so you know, if the dimension of the circle, diameter of the circle is say 40 mm. Okay, so it can be enclosed in a square of 40 mm, correct? Okay, so if I show you here in orthographic projection, if you draw a square circle of 40 mm diameter, so this diameter is 40, okay, and this diameter also will be 40. Therefore you can enclose the circle in a square of 40 mm. So to draw a circle in isometric, you have to first draw a square of equal to the of sides equal to the diameter of the circle. Okay, suppose the diameter of the circle is 40 mm. So first draw a square in horizontal position. We will draw first. So this is one 40 mm, and from here again 40 mm, and again from here take 40 mm, and from here it is again 40. So this will be 2, 3 and 4. Okay, now to draw a circle in isometric, what you have to do is, please listen carefully. From 1, draw a line, thin line, to the midpoint of 2 and 3. So this is the midpoint of 2 and 3. From 1, draw a straight line to the midpoint of 2 and 3. Then again from 1, draw a straight line to the midpoint of 3 and 4. Now from 3, draw a straight line to the midpoint of 1 and 4. So this is the midpoint. And from 3, draw a straight line to the midpoint of 1 and 2. So this is the midpoint of 1 and 2. Draw a straight line. Now you can see this is called as the 4-center method of drawing the circle. Okay, suppose this is the center 1, this is center 2, center 3, and this is center 4. Okay, now to draw the circle, please listen carefully. Take the midpoint center as 1, take the center as 1, and with radius equal to this length, okay, you draw an arc. Up to this point. Next, with center 2, radius equal to this distance, draw one more arc up to here. Next, with 3 as center, radius equal to this length, draw one more arc. You draw it with to scale, okay, using the compass. So then with center as 4, radius equal to this length, draw one more arc. This will be the circle in isometric. You can see it appears as an ellipse. Okay, so we'll stop here. This is the introduction to isometric projection. In the next class, we'll take up how to draw the solids in isometric.